Alright, this is video number 2 for the 14.1 lesson on limits. So to continue on with the notes, so when we talk about finding the limit of a function as x approaches some value, right, c, right, we denote that limit with this value of n. So the way we read this is the limit of the function as x approaches c is equal to n. Now you got to remember, as we're thinking about these limits and doing these limit problems, as the x value gets closer to c, right, we're not actually looking for that x value to equal c. Right, so as the x value gets closer to the c, the corresponding value of the function gets closer and closer to this n value. Okay, so also you want to remember that the function does not even need to be defined at c, as we're going to see here with the next example. All right, so here we want to try to find the limit of a function using tables. Okay, so in the last example we looked at a graph, and we're going to come back and look at graphs again to find limits. All right, but here we're going to try to find the limit of a function using a table. So we want to find the limit of this particular function described by this expression, and the limit as x approaches 2. Now you notice that if we actually plugged in the value of 2 in for x in the function, right, that the denominator goes to a value of 0, which, again, because this is irrational, it would be undefined. Right? You can't have 0 in the denominator of a fraction. Okay, but remember, when it comes to limits, it's not about actually plugging in the value you're approaching. Right? We are looking for, hey, where is the value of this function headed towards as we get closer and closer to this x value of 2. Okay, so we're going to approach it a different way. We're going to approach it by using our graphing calculator. All right, so we're going to make a table from our calculator. All right, so in your y equals screen of your calculator, you're going to enter in the expression for the function. So here I have x squared plus x minus 6 over x minus 2. Okay, so again, we don't want to graph this. We want to look at the table for this. All right, so the next thing we're going to do is you're going to press second and then table set. All right, so we're going to press second, table set to get to this screen. All right, and let's go ahead and start our table at 1. And we want our table to change by 0.5. Right, so we're going to be changing. We're going to start off our x value for this function, or this table, at 1, and we want to change it by a half. Okay, so we're going to press second, table, to get the table for this function. So now you're looking at the table, right? When x is 1, the output of the function is 4. When x is 1.5, we're at 4.5. And then we get to x value of 2, we get an error message, right? Again, we are expecting that because we said that if we were to plug 2 in for x, right, this function is undefined, right? Our denominator becomes a 0, and the function is undefined at that value of 2. So that's why we get this error message. So we shouldn't be surprised by that. We plug in 2.5, we get 5.5 for our output. We plug 3 in for x, we get 6, 3.5 in for x, 6.5, 4 in for x, we get 7, so on, right? So we want to look at this and say, all right, as we approach this x value of 2, right, you approach it from the left, meaning start with the smaller values, right, where those values look like it's headed towards. Approach it from the right, right, as we get closer and closer to 2, where is the output of this function headed towards, right? So it looks like that we're getting closer to 5 maybe, but we're not exactly sure. Okay, so what we could do is, let's go back to our second table set, and let's change it up a little bit. Let's start our table at 1.8, and let's change our table our x value by a value of 0.1. Okay, so we're going to change where we're starting our table, and we're going to change how the x values are changing. All right, so we press second table to go back to our table, and then we see, right, a little bit more easily that yes, right, again, here's an x value of 2, and we're getting an error message because our function is undefined at 2. But we notice that as our x values grow from some smaller value to 2 going towards 2, and as our x values shrink, our outputs are shrinking, and from both sides of 2, it looks like that we are approaching the value of 5. Alright, so like in this area right here, we are approaching that value of 5. Right. So the limit for this function as x approaches 2 is 5. Alright. So let's go ahead and try that for example number 2. Alright, so for this next example, we want to find the limit of this function, defined by e to the x plus 2. Find the limit of this function as x approaches 0. So again, using our calculator, we want to create this table. So we're going to enter in our function. We're going to create the table, so we're going to do second table set. For this one, we're going to start off our table at negative 0.1, and we are going to change our x values by a value of 0.01. So we're going to do second table to take a look at our table. So now we want to approach an x value of 0. Okay, so right now we don't see that in our table. So what we're going to do is we're going to scroll down here. So I'm just going to arrow down. And we get to this part of the table. Okay, so I'll stop here. So you see, right, as we approach 0, the x value of 0 from the left. Right, we came in from the left. Here, approaching an x value of 0 from the right. What is happening to our outputs of our function? Well, coming in from the left, coming in from the right, it is approaching a value of 3. So that's our limit. Right? The limit of this function as x approaches 0 is 3. Alright, so that's how you can do the problems from the homework where they ask you to use a table or to use a calculator. Right. You want to enter in a function into your y equals. You want to start your table at a particular value. Now you don't want to start your table at your c value, right, where x is going to. You want to start it off at some value conveniently to the left of your c value, and you want to try to pick a small enough increment to where you can see, right, and know for a fact, right, what the limit is of your function. Alright, so now we're going to move on to example number 3. So here's a little bit more complicated graph. As you can see, this is a piecewise graph. Right, so here's the function that defines this piecewise graph. Right, so this piecewise is made up of 5 different pieces. Right, so here's the graph for this first piece, negative x plus 1. That's a linear. For this one, it's going to be function that graphs a horizontal line. Right. This one, it just graphs the one point. Here again is another linear. X minus 1 is going to be from 2 to 3. It's going to be this part of the graph. And the fifth piece of this piecewise, negative x plus 5, is this part of the graph. The inputs values of 3 to 4. Alright, so from this graph we're going to find various limits of the function. So if we are looking for the limit of the function as x approaches 3, okay, so we are looking at the x value of 3 right here. Right, so if we're coming in from the left and we're coming in from the right, they are both approaching this location on the graph, and where that is with respect to our y-axis is 2. So the limit of this function as x approaches 3 is equal to 2. Or we could find the limit of this function as x approaches 2. Okay, so now we're looking at our x value of 2. So coming in from the left, all right, we're approaching this point. Coming in from the right, we're approaching this point. Now you notice that from coming in from the left or coming in from the right at that x value of 2, this function is undefined. But remember, right, it doesn't matter if the function's undefined or not. Right? We're looking for, hey, where are these values, where are the output of this function going to as we get closer and closer to this input of x, or in this case, input of 2, and it's getting close and it's approaching this value of 1. So the limit of this function as x approaches 2 is 1. Limit of this function as x approaches 1. Alright, so here's 1 on the x-axis. So coming in from the left, we're going here. So coming in from the right, we are approaching this value. Right? Approaching this x value of 1. Right, coming in from the left, we're going to this undefined value. Coming in from the right, we're approaching this defined value. Now, because the outputs coming in from the left and from the right are two different values, right? This one's going closer and closer to 0. This one's approaching 1, an output of 1. Because they are approaching two different values, this is an example of where the limit does not exist. Because they are approaching two different outputs for that one input. Okay. Alright, so we're running out of time for this video. We're going to have to move into video number 3 for the last 3 examples.